this is an objective with one or more than one correct answer. In this, we need to find out which of them are optically active. Now tell me, what is the main criteria to find out whether a given organic compound is optically active or not? Yes, here we need to find out the one which is chiral. And what is chiral? A molecule is said to be chiral when it contains at least one carbon attached to 4 different atoms or 4 different groups, isn't it? So this is called as the chiral carbon. And if a molecule contains at least one chiral carbon, we can say that that entire molecule is chiral. And that is a compulsory condition for a substance to be optically active. So for this one, we need to write down the structures of all these 4 compounds and identify whether they are chiral or not. First, let us write the structure of butanol, and it is like this: CH3, CH2, 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 OH. So is there any carbon which is attached to 4 different atoms or 4 different groups? No, isn't it? Because here the carbon is attached to 3 hydrogens, and here the carbon is attached to 2 hydrogens. Same with the case of these 2. So that is the reason why this is achiral. So let us write the structure of option B. It is 2-chlorobutane. So I am giving numbering from left hand side. So I write a chlorine at the second position. And this is the structure of 2-chlorobutane. And see here, if this is the carbon, this is attached to 4 different groups. One is methyl, one is chlorine, one is hydrogen, and the 4th one is the ethyl group. So this is chiral carbon. As this is chiral carbon, the entire molecule is said to be chiral. Means this one definitely exhibit optical activity. So this is one of our answer. Then let us write the structure of option C, that is lactic acid. And it is like this: CH3, CH, OH, COH. Even though it's not very much common in our day-to-day equations of organic chemistry, it's compulsory to memorize the structure of lactic acid, especially to work out some objectives based on optical isomerism. And see here, again this carbon is chiral carbon because it is attached to 4 different groups. One is methyl, one is OH, this is COH, and this is hydrogen. So definitely this is also chiral. Then when we take the case of the 4th one, that is 3-chloropentane. This is the structure of 3-chloropentane. A chlorine on the 3rd carbon. Now tell me, is there any carbon which is chiral? Definitely no, because this particular carbon is anyhow attached to 2 different groups here, chlorine and hydrogen. But on this side it is ethyl, and this is also ethyl. So this is achiral. So out of these 4, only option B, that is 2-chlorobutane and lactic acid, they are chiral, and that is the reason why they are optically active. So the correct answer is both option B as well as option C.